Okay, let's practice with trig derivatives. Number one, you notice that you only see the letter x once, but you see two functions. So that is definitely a chain rule. That is a composite function. The outer function is secant, and the inner function is 3x. So the first step for the chain rule is you take the derivative of the outer. The derivative of the secant is the secant of x times the tangent of x. And when you take the derivative of the outer, you never put in a blank. You never put in an x. You put in a blank set of parentheses. All right, because there are two x's in the derivative of the outer, there's two blank sets of parentheses. You put the inner as is in both places. Okay, so this right here is the derivative of the outer, the first step of the chain rule, and then we put the inner as is in both places. All right? So that's one thing to remember if your trig function's derivative consists of two functions. Finally, the third step, we take the derivative of the inner, the derivative of 3x, using the power rule is 3. So that is the derivative of the inner. All right, and then the only thing to do to simplify it is to get that 3 out front. Put the coefficients out front. So the derivative is 3 secant of 3x times the tangent of 3x. Number two, this is also a chain rule. My outer function is tangent, and my inner function is x to the 9th. So the derivative of the outer, z prime, the derivative of the outer, the derivative of tangent is secant squared of x, but we write it as secant squared of something. That is the derivative of the outer. The inner as is goes right inside that set of parentheses, so that is x to the 9th. So there's my inner as is. And finally, the derivative of the inner, we multiply it by 9x to the 8th. And this is the derivative of the inner. So to simplify it, I would put that 9 in the front. Coefficients go to the front. So we have 9x to the 8th, secant squared of x to the 9th. Number three, this is also a chain rule. We only see the letter x once, but we see three functions here, cosecant, e, and 10x. So that is a double chain. For my first chain, the outer function is cosecant, because this is the function that's doing something to the other two. We're taking the cosecant of. So my outer function is cosecant. The inner function is always everything else, e to the 10x. All right, I need all three of my functions accounted for. 1 here, 2 here. Now this is still a composite function, so my second chain, that outer is e, and the inner is 10x. Remember, if x is in your exponent, an exponential function, the base is always your outer function. So remember, on the first chain, we only do the first two steps. All right, so the derivative of the outer, for h prime of x, the derivative of the cosecant is negative cosecant of x, cotangent of x. So that is the derivative of the outer. All right, now the second step for this first chain is we plug in the inner as is. We have to put it in both places. So I put e to the 10x here and e to the 10x here. So that is my inner function as is, there and there. Now, this whole thing is my first chain. I did the first two steps. Now I start over and go to my second chain. The derivative of the outer is e to something. So there's the derivative of the outer in my second chain. My inner as is goes right in there. It is just 10x. And then finally on the last step, remember on this third chain, you do all three steps. Okay, so the derivative of the inner function here using the power rule is times 10. All right, so that is the derivative of the inner, and this whole thing is the second chain, all three parts. Okay, that's a lot. So to clean it up, we need to get the 10 out front. So we have negative 10. We still have a cosecant of e to the 10x. We have a cotangent of e to the 10x. And we have a plain old e to the 10x. You can't combine any of those e to the 10x's because one is inside the cosecant, one is inside the cotangent, and this one isn't. So there you have it. Tough one. Number 4, we have a chain rule. We only see the letter x once, but we have two functions, the natural log and cotangent. Our natural log is the outer function because we're taking the natural log of cotangent of x, and my inner function is cotangent of x. So, p prime of x, the derivative of ln x is 1 over x. We write it as 1 over something. So that is the derivative of the outer. We plug in the inner as is down in the denominator, cotangent of x. Make everything a fraction now. Oops. This is the inner as is. Now let's multiply everything by the derivative of the inner, the cotangent of x, and that is negative cosecant squared of x. And we just put it over 1. So this is the derivative of the inner. So there you have all three parts. The derivative of the outer is 1 over something. The inner as is the cotangent of x. The derivative of the inner is negative cosecant squared of x. So we multiply across the top and across the bottoms when we're simplifying this. So on top we have negative cosecant squared of x. On the bottom we have cotangent of x. And that is as far as you need to go. Number 5, when you see that notation, that trig notation where that exponent is in the middle, remember that applies to everything immediately to the left and to the right of it. So rewrite it. That's the same as the tangent of 9x to the 7th. Now you can really see what's really the outer function. We have three functions, tangent, 9x, and something to the 7th. Three functions, two chains. So the outermost function of everything is something to the 7th. The inner is always everything else, the tangent of 9x. This is still a composite function, so we need a second chain. The outside there is tangent, and the inner is 9x. All right, remember, this is just another symbol for derivative right here, d dx of y. All right, we go to work, y prime. Remember, the first chain, we only do the first two steps of the chain rule. And then on the last chain, you do all three steps. If there's more than one chain, you only do the last step of the chain rule on the last chain. So right here, the derivative of the outer, using the power rule, is 7 times something to the 6th. The inner as is the tangent of 9x. So this whole thing is the derivative of the outer. This is the inner as is. And those are the first two steps. That is all you do with the first chain. Now you start over. Right here, the derivative of the tangent is secant squared of something. That is the derivative of the outer. We plug in the inner as is, 9x. So that's the inner as is. And we multiply everything finally by the derivative of the inner. The derivative of 9x is times 9. And that is the derivative of the inner. And this is chain number 2. So this is a tough one. A lot of parts. Okay, so when we simplify it, we have a 7 times a 9. That's going to put a 63 out front. Get all your numbers to the front. We still have a tangent of 9x to the 6th. We still have a secant squared of 9x. And there you have it. Okay, number 6. Hey, we see the letter x twice, which means we are multiplying two separate functions together. The first function is the cosecant times the second function, the cotangent. This symbol right here, that just simply means to take the derivative. That is a symbol for the derivative. All right, don't let that confuse you. All right, so 1d2 plus 2d1. Let's get started. The first function as is cosecant of x. Then we come back with d2. The derivative of the cotangent is negative cosecant squared of x. Plus, we come back with the second function as is, the cotangent of x. And then we need the derivative of the first. The derivative of the cosecant is negative cosecant of x, cotangent of x. So that is your product rule. 1 as is times the derivative of the second plus the second function as is times the derivative of the first. Now clean up each term. Okay, right here you have 3 cosecants. So it's going to be negative cosecant to the third of x. Over here we have a cotangent and a cotangent. So I'm going to make this a negative because that is a negative right here. So we'll change this to negative. So we have a cotangent squared and we have a cosecant. So I'm going to put the cosecant first, cosecant of x, and then cotangent squared. All right, now we can factor. Remember, this is one big binomial. This minus this. They both have a cosecant. There's 1 here and there's 3 here. So they each have at least 1 cosecant. You pull out the smallest number that you have. So I'm going to put a cosecant of x out front. You can either pull out a negative or a positive. It doesn't matter. All right? To get each new term in your binomial, you divide. If you divide this term by the common factors, cosecant cubed of x divided by cosecant of x gives me negative cosecant squared of x. And over here, if I divide this term by the cosecants cancel, and I have cotangent squared of x. All right, and that's as far as you need to go. Okay, number 7, you could use the product rule because you definitely have 2 separate functions multiplied together, but this is a lot easier if you simplify it first. Okay, if you recognize these are reciprocals of each other, okay, so rewrite one, okay? We can leave the tangent alone. I'm going to put it over 1, but we know that the cotangent is the same as 1 over the tangent. Those are reciprocals of each other. All right, so that simplifies to the tangent of x over the tangent of x, which is equal to 1. All right, now you take the derivative, and it's way easier. The derivative is 0. So be on the lookout. If you can simplify it first, you can avoid those big, long, messy rules. Number 8 is another one. If you simplify it first, you can avoid the big messy rule. This could be used, you could use the quotient rule because it is a fraction, but that's going to be a big mess. So simplify it, rewrite it. All right, the cotangent is the same as the cosine over the sine. All right, so that is our numerator. All right, now if you recognize it, we can just leave that denominator alone. I'm going to make it a fraction though, so we have a fraction over a fraction. Because if you can recognize, you've got a cosine up here. When we divide the fractions, those cosines will cancel out. Okay, so now what we're going to do is we are going to multiply by the reciprocal. That's how you divide by a fraction. Okay, so we leave the first fraction alone. Cosine of x over the sine of x. We change it to multiplication, and we flip that second fraction. So instead of cosine of x over 1, it is 1 over the cosine of x. All right, now when we simplify those fractions, hey, those cosines are going to cancel out. All right, so that gives me 1 over the sine of x. All right, now let's keep simplifying because we know the reciprocal of the sine is the cosecant of x. All right, so that simplifies to the cosecant of x. Now when we take the derivative, it's very easy. Negative cosecant of x, cotangent of x. That is in our derivative flashcards. So again, be on the lookout. Chances are is if you have a fraction with 2 single trig functions in the top and the bottom, you can simplify it first and then take the derivative. All right, that makes it a lot easier. That's the end of the first video. The back side of this will be on the next video. Thanks, calculus.